Quarantine has allowed me to spend a lot of time with my pets, including my hedgehog Percy. Now, Percy has recently gotten himself in a little squabble with my cat Marie. Don't worry, no hedgehogs were actually harmed. But I wanted to figure out a way that Percy and other hedgehogs could better protect themselves. So with my knowledge of quantitative genetics and my super cute hedgehog, I decided to improve my hedgehog population by lengthening their spines. My original population had a mean of 30 millimeter spines, with a standard deviation of 5 millimeters, and it was normally distributed. For my mass selection experiment, I then calculated my truncation point, using the formula x sub t equals x sub 0 plus z times the standard deviation. When I plugged in my values, I got x sub t equals 30 plus 1.282 times 5. The value for z comes from this table, in which I used the value of 0.1 for my proportion selected, being that I selected the top 10% of my population. I then got my truncation point of 36.41. This is the minimum point I'm going to select from for my selected population. In other words, I did not select any hedgehogs in my population with spines shorter than 36.41 millimeters to breed. I also calculated my selection differential, which told me the difference between my selected population and my original population. I did this using the formula S equals I times the standard deviation. My value for I came from the same chart as my Z value. Plugging in my values, I got that S was equal to 1.755 multiplied by 5, giving me a selection differential of 8.775. So my selected individuals had spines 8.775 millimeters longer than the mean of my original population. This allowed me to figure out the mean of my selected parents using the formula S equals x sub s minus x sub 0. So the mean of my selected parents was 38.775 millimeters. These parents with long spines were then bred to give offspring. The realized heritability for this population was 0.67, so the proportion of phenotypic variance that is attributed to additive genetic variance is 0.67. And I use this to calculate the response to selection using the formula R equals the realized heritability times S, or my selection differential. When I plugged in my values of 0.67 and 8.775, I got R equals 5.88. So the mean of my selected offspring was 5.88 millimeters greater than my original population, giving the mean of my offspring to be 35.88 millimeters opposed to the 30 millimeter spines of my original hedgehog population. If I continued my mass selection experiment indefinitely, eventually my response to selection would decrease because there's a limit. With hedgehogs in particular, this was due to an unhealthy extreme phenotype. The hedgehogs with the longest spines actually suffered from spine breakage, causing more harm than good. Hedgehogs typically have very strong spines that don't break, but with spine breakage, hedgehogs cannot protect themselves from predators properly or properly absorb shock waves.